Hello. In this webinar, we're going to be talking about what's new with RISAFloor. My name is Debbie Penko. We've made a lot of changes into RISAFloor version 11, and I'd like to talk a little bit about what's going on, the changes we've made in RISAFloor version 11, as well as we're going to get into RISA 3D version 15, but we'll focus on what has changed in RISAFloor. We've made a lot of changes and enhancements, things to help make a little bit of modeling, design, kind of across the board. We've made changes to help you get into the model much faster and quicker. So starting out, we're going to talk a little bit about the modeling features. So modeling, trying to get your model up and going, the most important piece is starting with a project grid. So we've made some enhancements to that project grid, starting out with the actual project grid itself, as well as trying to get in from importing. So I'm going to show you how Revit structure works a little bit better with our newer project grid. The next thing is added is DoubleClick Dialogs for beams and nodes. This is something that's been in RISA 3D for a very long time, and it's a way to modify and work with your model within RISA 3D. And what we've done is we've added that directly into RISAFloor. So ways to help work on your model if your beams or your nodes are in the wrong location or any of their information you want to change, we'll be able to do that quickly using this DoubleClick dialog. So if you're familiar with RISA 3D, you'll be then very familiar with what that behavior is over in RISAFloor. Another thing that we've added is coordinates display. So this is actually across the board for all of our programs. You can now see the coordinates as you hover over them. It makes it really easy to understand what's going on in the model and find things because you quickly can see that coordinate. So I'll show you that feature, as well as I'll show you how to turn it on and turn it back off again, just in case you want to see that. Move tools. Again, this is a feature that's been in RISA 3D for a really long time, but now as we've added it into RISAFloor, so you can move portions of your model, walls, columns, beams, nodes, anything really in the model can be moved around the model. This is something, again, for changing your model. So if you've laid out everything and then you need to go back and make changes, moving it makes it really easy to do that in this method. And I'll demonstrate that as well for you. Area load query tool. So this is something very specific to RISAFloor, as RISAFloor has layered loading in it. A lot of times what we do in RISAFloor is we talk about the loads are going to be some uniform area loads in RISAFloor. Now that means that you can add loads on top of loads, different load cases, and it can be very complex of what you're looking at in one location, how much load is there. So what we did is we added a tool so that you can just find exactly what loading is at that location. This will help identify exactly what you're looking at, and then we can show you displaying of different things as well for loads, but really identifying what the load is at a certain location makes it all the more comfortable that you've applied the loads that you thought you applied into that model. So I'll show you that as well. So those are more of the modeling side, applying the loads, working with your model's geometry. Those are kind of the modeling features that we've put into. And what I also want to show you is we've added a lot of design features as well. So in the design side, what we've added is we've added parapet heights for walls. So for a long time we've had column parapets, but walls are also important to be able to have parapets on them as well. So you can do that in the RISAFloor model, but alongside with those parapet model is you want to actually load that. So now we can also apply the loads to those parapets. So you're going to see higher loads for the wind loading. And those parapet loads will be applied directly into the automated wind loading. And I'll show you that as well. And lastly here, we're going to see is going to be the mezzanine loading. So you can turn on and off your mezzanine loading. For an example, there's times when you're not going to be applying load. So there's buildings where you may not want to have load applied for that wind, for the case of mezzanines. And we can turn it off right there in the floor spreadsheet, and I'll show you that. And then the big ticket item here is our semi-rigid diaphragms for all floor types. So now you can choose from a rigid, semi-rigid, or flexible diaphragm all in the same model. And that makes it really easy for you to understand the movement of that diaphragm, and we'll see how the loads get applied and how that gets displayed on our screen in RISA 3D. So diaphragms are going to be defined in RISAFloor, and then we're going to really review it in RISA 3D. But let me show you that all in action. So let's jump ahead and go into the program. So I'm going to start by kind of jumping into RISAFloor. So I'll just start with a new model. Let's go ahead and just do a file new just so we see what's going on here. There's no change to my floor plans, but I'm just going to choose the basic beam supported floor, and I'll just tell the program it's going to be at 10 feet. Now, the project grid is going to be popping up here. It's a little different. This looks more like a dialog where it's asking us questions very similarly to what we have in our drawing grid. So you can either lay it out as a rectangular grid parameters or a radial grid parameters. Let me just show you the rectangular grid. It's pretty straightforward. You just tell the program the z-axis increments and the x-axis increments. So right now we're telling the program here start with a 20 increment, 4 at 30, 20, and 10, and then we're seeing it 5 at 25. I just say apply. Now, one of the features we added is if you made a mistake here, you say, oh, for example, that I didn't want that to be a 20 at the start, I actually wanted it to be 10. We can just push undo and switch that to be 10. So it helps you sort of view it. It's like a plot preview, so we see exactly what happens, and then we can commit to it and say OK. The other options we added was radial grid parameters. So that helps you do a radial type of project grid as well. I'm just going to actually go ahead and say OK from there. You can now double click on any of your project grids, so you can make changes directly to that. You can turn on and off your start bubbles, create, so I'll just show you that. You can turn off that, turned off the bubble down here. You can create parallel lines, move the lines. So it's a much more friendly tool here. What I'm also going to do is just show you how we can import directly from Revit Structure. Since we have, let's see, the project grid is now a spreadsheet format that really makes it friendly for us to import from any type of a Revit model, where we can do really the sky's the limit over there. So I'm going to jump over into Revit and show you a model here. If we open up a grid I've laid out in Revit Structure, this grid here has got a lot of different things going on in it. So I put lots of straight lines, I've skewed a line, I've given it a radial line, and really you can make, S-shaped lines, whatever you want for your project grid. I just tried to get creative with it. We can save that, and then we can send it directly out to RISAFloor. So using the add-ins, export to RISA, and I'm using 2017 link here, I can say RISAFloor, and I'm going to go ahead and say I'm going to export. Really what I'm worried about is this project grids. So I'm going to say OK, and it'll save my model, and it's going to launch in the background here over to from Revit Structure directly into RISA. And I've got some beams and columns with this model, but I really wanted to concentrate just on what we're looking at here, which is just this project grid. So it'll launch right in the background, and I'm going to pull that up for us. Here we go. And here we go. We've got our project grid brought in directly from Revit. So it looks like we've got some of our arcs coming across, the skews coming across. I laid some columns kind of strangely out right on top of that arc, but it just shows really everything that went across here from the Revit model comes across right into our RISAFloor. So this Revit link will be coming out soon with all of these changes to support these great project grid that you have now here in RISAFloor. So I'm going to jump over here a little bit to another model just so we can kind of play around with another model and see here some of the other features I talked about. So the DoubleClick Dialog was one of the ones that we talked about, and that one here, if I show you here, I'm going to double click on any of these members, and you get this member properties information. Just like this looks like in RISA 3D, we have all the information that we might need, the joint information, if we wanted to add connection information to it. We can tell the program if it's pinned or fixed, if it's an outrigger, if it has any eccentricity to it for attaching to the columns, if there's any camber, jumping over to properties. So in RISAFloor, you'll notice here is we always really work on shape groups because we're talking about design in RISAFloor. So the program is actually setting up a design family, which is like wide flange or angles or channels, and that's most typically what we do in RISAFloor. But you can also call out an explicit shape and just find a shape right from the database. So finding a specific shape that you'd rather use. If we had one specifically called out, it might pick that one up for us and we'd see it there too. So You get to see all the properties of this shape listed, and then again here you'll see the design properties of that. So unbraced links, if this was a composite member, we would see that here listed right here. The blue versus the red, you can talk about the gravity versus lateral, and that can be toggled right here as well. So lots of great tools in order to manipulate that beam. The columns themselves as well. So if we can look at the columns, if we double click on a column, this column stack manager has been around for a while, so you may be familiar with it, but you also have the ability to change its coordinates directly inside of the column stack manager, just like you might want to change something in the beam dialog. The node location one is also really helpful. So if you turn your node labels on and you can double click on any node. Now that gives us the ability to move that node up and down, side to side, however you might need to. And that makes it really easy to make a change fast. Instead of having to use our new move tool, which is a great tool, but in order to just scoot this beam up or down, it's so easy to just double click on it, say, hey, actually I meant it to be at 92 feet, not at 92 and change. So I'll drop that at 92, and the rest of these will go to 92. So for example, we could do things like that. It's going to see this is a shared node, so it's dragging a width, things like that. So you can go across the board, or you could then use the move tool, and we'll do that here shortly. So let me just scoot that back. So that's for beams and for nodes. That's an easy way to manipulate using the double click dialog. You can also see what's happening, as I mentioned, that we have that coordinates cursor dialog display. So if you see everywhere I'm hovering, you'll notice it shows me on top of a node, or if it's a location of a snap location. I get that coordinate listed right there on the screen. This is a great feature because RISAFloor in particular, I get lost a lot of times. Where am I in the model, especially with where it's, sometimes 0, 0 is not the corner. I drew it in 0, 0 in the corner, but most times in real life that is not really the corner of the model. So when coordinates come up, you're always looking like, where is that in the model? This really helps orient us where things are. So even without this turned on, you can still hover, so you don't have to have that joints turned on or nodes turned on. You will be able to hover and still see it. But in the case that sometimes when I take screenshots and things like that, it bothers me to have it there, you can always turn it off. You can just go to Tools, Application Settings, and you'll see in here there's a Show Current Location Coordinates next to the cursor. You can check that on or check it off, and it would turn off that right there for you. So if you do not want to see it, you can turn it off. But I do think it's a great tool. Let's also talk about the move tool I mentioned. So we can now move things. We've had copy in the modeling here for a little while. Next to it, you'll see it's a move tool. Very similar. Move tool is based on the selection states. So let me go ahead and I'm going to unselect my model and just kind of show you some of the tools we can do. So I just want to say, let's select this entire row at the bottom. And what we can do is tell the program, hey, we want to move that whole row, and you can move it either by point to point. If I had a point I might click to, but actually most likely you're going to have a distance. So I'm going to say, let's move it down by 10 feet. So to do that, I just say -10 direction because I'm going downward in my model in the X direction. It can tell you the program what you want to move. Do you want to move just the beams and the columns or just the walls, joints, things like that? But I'm going to move everything. I can say apply, and it says to me, hey, what do you want to do with these columns? Are we moving just a single column or the whole lift? And I'm just going to say entire column stack, go ahead. It's actually one story. It's not a big deal there. So just if we tell the program to remember this, it will actually do it for all. There we go. Now, one thing it did is it discontinued this wall. So how do I want to support this beam now that's there? One of the nice things we've added at that double click dialog, I can just say, hey, instead of being at 0, 0, 0, let's go to 0, -10. So I can just double click on that node location and say -10. All of a sudden, now that joint sits over there, and that whole wall is now expressed all the way to the base of that. So making changes like that is so easy now. When we run the model, it will model merge, so it will be all set for us at that point. So we've got that move tool, and in conjunction with our double click dialog, really helps us work around the model much faster. We could scoot things all around just by using that double click, like I said. We could have moved all of those items down, but it was just as easy to use our move tool. Now let me show you a little bit here about the area query loads. Let's go ahead and hang on for a sec here. Let's go and put some openings into this model just so that we don't leave those blank there before we move to the query. I'm going to go ahead and put an opening in right in this spot here. Okay, well, this will be good for us when we're looking at our semi-rigid diaphragm. We'll be able to see a little bit more information and interesting things to look at with semi-rigid. Okay, so for loading, what we can do is we can see a lot of things that happen in the model based on this loading that we have here, show area load types. And what that does is it helps us display with or without the defaults. If you're familiar with RISAFloor, you know you have area load definitions, which are defaults, and then you can add additional loads on top of that. So in this model here, we have a default on floor plan 1, which is this lower level we're looking at. It has an office area load of a default, and that load is showed right here. Okay, we see that right on that office area load. And then we have additional loads on top of that. So for example, here we're looking at without the default, with the default, we can see over here we have layers of load happening over here versus here. And sometimes it can be just a lot to look at. You say, oh, okay, what's the office load again? If we look at that area load, oh, okay, so it's over here. What this area load query tool does for us is it says, without anything displayed, you don't need to have it displayed. You can just click on that and say, okay, what's happening out here? Let's see. So if you click on that area, it'll tell you exactly what's happening per this load combination. So as we scroll through the different load combinations that we created, and that might be something you can look at before you open up this tool, but we can see different load combinations are creating different loads in here as we scroll all the way through. So we can see, and then it gives us the total load per that load combination in this one little area that I clicked. So I scroll down and see all of that. This model happens to have both, in our load combinations, I've got both ASD loads as well as LRFD loads. So you can see it's kind of a collection of different loadings. And that's what that area load query is doing for us. So we click on into this roof area, we'll see different area loads. And one of the nice things too is it's showing us our deck self-weight, whatever the loads are for that, as well as our superimposed and any of the dynamic loading and vibration loading. So it gives the whole collection of loading that are happening based on this load combination selected. Really, really helpful way to identify what's happening. So this is a really great tool to work with as well. So I'm going to show you guys the full model. If we look at this full model here, we can see it's just got really what we were looking at. I just sort of made a kind of a simple model where it has 2 levels going on, and on each level here we've got some framing as well as some walls situations on both sides. And I want to do is kind of talk about some of the parapet stuff that I mentioned. So for parapets, you can do things a couple different ways. In this floor plan, we have parapets on our upper floor. This is our top floor up here, but we maybe don't have parapets on our lower level. So I'm going to just turn those nodes off so we don't get distracted by that. There we go. So if you're looking at the parapets, this is our lower level. Maybe we have just parapets on this outer here, a little balcony area. So to do that, maybe the quickest way would be just to do it graphically. So going into the columns, you can say modify these columns, and let's give ourselves a parapet distance of maybe 6 feet. And I can just say, okay, apply that and just grab the columns that are going to be, these are the 3 columns on out there, they're going 6 feet up. Now for the wall panel, I can now make this wall panel as well a parapet. So what I want to do is go to say modify wall panels, and I'm going to go ahead and jump into here, parapet height of 6 feet. Again, I just say apply and click individually by clicking on that wall panel. If you ever get wondering if it worked, the best way to do that is just to verify it by looking at that. You can see now, there's that little parapet we were talking about. So what I'll do is I'm going to go ahead and go back to that. And for the wall panel in particular, I want to get some design. So I'm going to just go ahead and just give myself all of my regions for my whole wall panel there. So all I did was just delete the lower one, and I added up an upper one there. And that's using this automatic wall generation for regions. So we've got a concrete wall over here, and then I'm going to go to the top floor. Now for the top floor, we're assuming that there's a parapet around the entire thing. So the easiest way is, instead of picking out the walls and the columns individually, is just to jump right into the floor spreadsheet and say, okay, this entire floor has a parapet right there. We've got a column that says this is a parapet. And we can tell the program, yep, just give me a parapet height of 6 feet. So inside there, that whole thing is going to go 6 feet. You also notice here I had the no wind and drift location checkbox there. So if we had a mezzanine level, we would just check this on for mezzanine, and that level would not get wind load applied to it. And what I'm going to do is go ahead and go into the full model view, and then we can verify it directly on our screen, seeing all that those parapets are at the uppermost level of the whole top floor, as well as on my little roof area, decking area over there. Now, I'm going to go, and you can also verify this right inside of your spreadsheet. So for your column spreadsheet, you can see I have a parapet columns right here, which is a way you can also put it right into the program if you wanted to, versus you could have done it, we did graphically. Okay, now once we've run this model, so I'm going to go ahead and run this model. It's going to be calculating all the loads down the structure. If you have a wall panel here, we're going to be accounting for that upper portion of that wall panel, calculating the loads down the structure. You'll notice here I have all sorts of different types of members going on. So there's lots of loads being designed. I use that load combinations for LRFD as well as ASD because I'm kind of doing a collection of different things in this model. So it will calculate all these forces. Whoops, one thing we'll have to redo that one more time is I currently have a rigid diaphragm, and I do want to show you guys the semi-rigid diaphragm, as that's an important one to look at as well. So I'm going to say okay, and we'll just go ahead and we'll look at this model here just real quick before we switch it over. Now, the diaphragm does not make a difference here. This is going to give us all of the gravity information. So this is not really in respect to to our diaphragm, but when we're about to take it over to RISA 3D, that's important to us. So we've got our designed information for our floor plan 1 and our floor plan 2. I used some of our special joists here, it looks like. I've got joists in design, and then below that I have some just standard wide flange. I did not use any composite design. You could. In this case, I just decided to just do a collection of different types of framing. So the diaphragm information, let's go and take a look at that. So if you go to the diaphragms, you now have an option of a rigid, flexible, and semi-rigid, as I mentioned. So rigid and flexible have been in the program for a little while. Flexible has been one of the things here we added. A lot of folks use that with maybe wood modeling. And then with semi-rigid maybe is a good compromise between the two. We're actually going to take this and get a finite element mesh inside of RISA 3D. So it's going to be a little bit more realistic. And what you want to do here is give a semi-rigid diaphragm, and then you're going to define the material that you'll be using. So that material is based on the material in the general tab here of the materials. So a newer thing we've added is general plywood, but you can define it as a concrete, aluminum, steel, plywood, anything you choose in here can be listed. So I'm going to choose to be general steel. I'm assuming this is a metal deck of some sort, and I've decided a 1/2 inch thickness is going to be the stiffness of mine. What you might want to do is go ahead and think through, really, this is going to make a difference in what the stiffness of that semi-rigid diaphragm is over when you get to RISA 3D. So you think through about how your deck or your diaphragm is behaving and what kind of thickness you want to use there, based on the stiffness that you've described that. So here, this is the stiffness of the steel, and then we want to see how we want it to behave. Once we go over to 3D, that would be how thick you would make it. So what I'm going to do is I'm going to now solve it one more time, and we will then, we shouldn't see any change of results here in RISAFloor based on this change, but we will see it over RISA 3D when we get over there. And what we're going to be applying over in RISA 3D is going to be all of our lateral loads. So our lateral, we're looking towards our lateral seismic and wind, and in particular things that have changed is the wind. We're going to see a lot of differences than we had previously because of these parapet loads that we added. Seismic, we will see the loads from those parapets, but really the calculations of these parapets are going to be a little bit different, and wind is actually going to be pretty amplified in those parapets. Okay, so now we have a solution. So we see nothing really changed. Everything looks the same as what we thought prior. But what we want to do is now take this over to RISA 3D. So using the director button in the top right corner, I go to RISA 3D. And I'm going to see first thing that pops up is my wind load calculations. So hang on just a sec as we jump in. And you can choose any kind of code you want, any wind speed. You can choose the category, and if you have any topographic effects there, what you'll see below is going to be so just a general input telling us the echo of what we put into the program. And then the program calculates the width and the length of the structure and starts to calculate what load is going to be applied to that structure. Below this, we've got a nice map of what's going on in this model. So you'll see the parapets are drawn out. Now, before we even look at that for a second, what RISAFloor is, or excuse me, RISA 3D is doing is it's calculating the values that are coming across on that diaphragm. So it's going to calculate all of that windward and leeward load and put it as an X and a Z direction, and it calculates it into a kips per square foot, and then turns that into a kip force directly onto the diaphragm. Now, the other piece is going to be the parapet portion. So one of the things to notice is it's a pretty significant chunk. So floor plan 2 is our roof level, and we are seeing a lot more in that roof level due to this parapet. This is additional load. So we'll see it's floor plan 2 is 9 kips in this direction, 29 kips is the parapet, and it's now totaling for 39 kips on that floor level. A lot of load. Same thing happens on the lower level, but on the lower level, it's just happening in this one little portion we created. So it's drawn out kind of as a roadmap for you here as the parapet summary, and this roadmap shows us that it's broken into chunks, and that's what the parapet loading is calculated. And it's going to be the force in the X direction and the force in the Z direction applied to these small coded numbers here. So 1 through 6, we can see right there. These are the loads applied to it. Then it's summated, so it's going to be the total summation of this list is then applied up here as additional parapet. So 17 there. So if we counted up all of this, it would be 17 kips right here applied and then added into the total floor of a 62 kips. So if you had a rigid diaphragm, we would just take that and put it right in the middle and dump it and go from there into the rigid diaphragm. We're using a semi-rigid diaphragm, so it'll be a little bit different. Let me show you how it gets applied as a semi-rigid diaphragm. You can say OK. Now, the seismic loading here is pretty similar. Nothing real major has changed, although you will see additional weight due to the fact that you have those parapets in there. So the weight calculation, if we had no parapets, would be a little less, but otherwise you're not really seeing much different than what we always see, which is where you can calculate, you put all your seismic information into the program, you put your location information into the program, with the directional of the R's, so I used walls in one direction, and I used brace frames in the other direction, so I get 2 different R's listed there. But what you're seeing here is a calculation of what we did based on the seismic loads, and then it takes it into a force in the X direction and a force in the Z direction based on that weight. So we've got a seismic load calculation, and I'm going to say OK. Okay, so now, if I mentioned if we were a rigid diaphragm, we would just see some loads that would be dumped right into the diaphragm. But we are not. We are a semi-rigid diaphragm. So what's going to happen is going to be slightly different. So opening up your basic load cases spreadsheet, it will look similar, but what you'll see here is, for example, we see things like we have the wind loads listed here are blank. Those go into what we have called a semi-rigid wind load. And that's shown at the base of the basic load cases spreadsheet. You see it's shown here as a little grayed out number. You can click on it and go to the diaphragm loading, and you see it goes right into the diaphragm. This is just shown for your verification. It's gray, so you can't really grab it or apply it or change it or anything like that, but it just shows you the number just in case for some reason you can't see that graphically. You can always see it right in a spreadsheet format. Let me show you what that looks like on the model. So if we go straight to the wind loads at the bottom here, wind load in the X direction. Let's see here. Oop, we want semi-rigid, excuse me. So we've got semi-rigid in the X direction, and this is the plus X direction. What we're doing is we're taking all of that wind load we prior calculated, and we're smearing it across the edge of each one of these diaphragms. So we've got a diaphragm kind of going around the edge here. We see all of that wind load. Wind load is going to be applied to that surface of the edge of that diaphragm. So you can look at it in the X and the positive X and the negative X. So you see the 2 directions, the windward and the leeward directions, and then we can then see it in the Z direction, as well as the positive direction, as well as the negative direction. So it kind of points on different sides of that, and you can see that how that flip-flops right there. So that's wind load. And so when you're creating your load combinations here, I'm going to just go ahead and put some standard loads combinations in here for some dead load and live load. But I'm going to jump over to the wind load for a second. So for wind load, what you want to make sure you do is use X and Z with the generate semi-rigid diaphragm loads. What that's going to do is it's going to pick up all of these lower level semi-rigid diaphragm loads that we created for us. So we're going to say create those ones here by saying generate. And when we close this out here and just take a look at the load combinations, it picked up what we call here is these are the ones that we're worried about. So they are the WL plus X, WL minus X, WL plus Z, WL minus Z. Those are the ones that are being pulled into here. So you'll see them right there. Okay, so actually it's right here, just in case. So these are empty because we're not using those right there. We're using them from here, which is down over here. So we can kind of verify that is there. And so you've got your wind loads applied, and now you're going to worry about your seismic loads. For seismic loads, we can just look at the ELX, for example, and that is a little different. So seismic is based on, if you think about it, wind blows onto the side of your building. So we smeared it along the edge. Now for seismic, what we're doing is we're doing it based on the weight. So instead of just smearing it in one location, we take it and distribute it based on the weight of the entire slab, or the entire, this is metal deck. So, but anything that you have for the semi-rigid, it's being applied along that entire thing. So this participates along the entire actual diaphragm. So we apply the wind loads, the earthquake loads in the X direction and the Z direction, and you can see that they're smeared all in each portion there. Portion of the column weight goes into that. Everything gets kind of attached to its closest element there. So you've got loading all in there. Now let's go ahead and go into load combinations and create load combinations for the seismic X and Z. And I'm going to say generate those, and we'll close that. And then I'm going to go ahead and I'm going to say we have some LRFD loads as well, so I'm going to go ahead and create some of those as well. So I'll just flip the flag, and we'll start with wind just because we want those. So generate that, and then seismic. And we'll go ahead and say X and Z for that. Now, one thing you want to do is turn on P delta. I'm going to say fill the block with yes for P delta. So we get all of these filled out. Okay. Now we can go ahead and solve the model. I'm going to go ahead and say solve the batch and envelope, and it's going to run through all of these different load combinations. So there's a lot of load combinations happening, and we're going to go through each one of those, calculating the forces in the members, applying all of those different, smearing them across the diaphragm, taking those loads and applying them into our semi-rigid diaphragm. At the end, we get to see what this semi-rigid diaphragm looks like. It's not being meshed until it's complete. So the meshing takes place right now. The model is saying, okay, where do I need to submesh this into plates, and how do I do that? And that all happens right this instant when we apply these loads. So you'll see wall panels are being submeshed into the diaphragm, which is being submeshed into different pieces, and then the loads are being distributed based on the stiffness of that diaphragm. Okay, with solution present, we can now take a look. Let's first start by just looking at what that diaphragm looks like. So if we go ahead and switch on our diaphragm, it can get a little messy, so we might want to see just one level at a time, but I'm going to sort of, let's go ahead and unselect a level just so we can see just one level, and we'll look down on this here. So just locking out that upper level. Now we can just see what's going on this lower level. So what's nice is that we see, if we just turn on our plot options, we see there's the mesh of what's happening. We could also turn on contours of what's happening on this here. So if we want to show the contours of this different, we can see how the forces are running through this plate diaphragm. We can see, let's see something that might give us a little bit more information. There we go. FZ, maybe FX. And one of the other pieces I like to always look at, we can see a little stress is happening along the way. One of the other things I always like to look at is to see the deflection of this diaphragm. So this is just for load combination one I'm just showing here, but we can go maybe into something a little bit more interesting. I think we get into some of our diaphragm. Let's look at our load combinations just to check. So maybe our wind load combinations, those were pretty decently loaded here. So if we look at load combination 4, for example, we can go into the deflection and review load combination 4 for what we had on for deflection. So say OK, and we can start to see how that deflection behaves. One of the things I always like to do is sort of amplify it so you can just see a little bit further. So the diaphragm is behaving, distributing it to the members. The members are now, we can see that walls are deflecting slightly. I've amplified this by 400%. So we're seeing a pretty exaggerated view, but it helps really to see and understand how the model is behaving. You could turn the whole model on and see all of it. As long as it's not a giant model. Sometimes I like to isolate versus seeing everything at once, but you start to see what's happening and how the model behaves. So you've got even showing us how these braces are behaving. It's an easy way for us to see how that works. So you've got this loads applied through the semi-rigid diaphragm, and one of the things to note too is that when you're semi-rigid, it kind of makes a little bit more sense logically. There is no diaphragm where the openings are, helps you see that a little bit better. We look down on this here. I'm going to lock out the bottom and just zoom down. So this was our upper level. We actually had no openings in our upper level, but let's go ahead and look at our lower level then. So we have lower level. We see we've got, let's unlock everything and just show this level. And we can see if we lock it out and go back there. So you can see how these openings are behaving in the model. This is one of the ways where you start to really see, I kind of made Swiss cheese out of this portion, and you're seeing how that's affecting how this distribution goes into this portion of the model. So it's a really great tool in this case to see all this information based on how the actual plates are behaving. So you can then you can switch things around. You could go ahead and run a rigid. A lot of times people want to compare, so you could go take this back over to RISAFloor. So you're going to want to make sure you define it back over in RISAFloor to a rigid diaphragm. And you'd be able to go ahead and say what was the joint deflections over in RISAFloor versus what it was in RISA 3D for, as a rigid diaphragm. So we'd rerun it in RISAFloor, bring it back as a rigid diaphragm, and then we'd be able to see what are the deflections for what's happening in this model. And you'll also see the load distribution. So deflections is just a way to see this, but it's really important to know that also if you're not, it's not just the deflection, you're looking at really the structure is behaving differently because the loads are distributing differently to the members based on the stiffness of that diaphragm. If we look here, we can see some of the information for our parapet. I want to show you, I ended up, this was the concrete parapet wall that we added on this lower portion here. And we can get design information on the R2 and R3 region. So that's the upper portion of that. So if you looked at the upper portion, this was the parapet loading in plane and out of plane. You can see how that's being added into the model here for that R3 versus if we're looking at R2, which is the base of the model. So it's designing that concrete wall for you there. You can then also get all of your lateral information out of this model. So we would, if we're going to keep going with this model, we would take a look at our design results, making sure, looks like we have a couple failures, and we start to worry about how to work on those models. So I would go and design this based on that. One thing we'll last want to do is just talk a quick bit about our new drift calculations that we added into RISA 3D. So I'll go ahead and just get rid of all of my different deflection. Let's pull that off, and let's go back and turn off my diaphragms and just start here with just a rendered model here for a second. Story drift here, if we click on the results toolbar, there's a story drift option, and this is added into RISA 3D version 15. What we can see here, we have a Z direction, a service load direction, and a strength, service loads versus strength loads. And we can see a little bit of information here. We did a batch solution with envelopes, so we're saying minimum and maximum. But RISAFloor is automatically bringing over our floor elevations. So we have floor plan 2 and floor plan 1, and it's showing us the information directly from RISAFloor. So this is a little different. If you were in RISA 3D by itself, you would define story drift based on the elevations. But since RISAFloor knows that there's a floor level, it's doing that automatically for us as we come to RISA 3D. And then we get some information about the story drift, the locations, the load combinations, and then a ratio. The best way to understand the story drift here is if we open up our help file. And a way I do that is I push F1 when I have my mouse hovered into that cell here, and it goes right to the drift results location. So I get some information on the drift topic, but I'd like to scroll down below that and just show you kind of this picture in particular. So the picture we see here gives us an information about how this works. Story drift is defined directly showing here based on the first level is easy. It's just the deflection. That's the story drift at that level. The second level, what we do is we take a difference between the first level and the second level, and that's the drift. And then it goes on and so on as we go up the building. The ratio is similar, so the ratio is going to be the drift, that deflection there, divided by the height of that floor level. As we go up the structure, what we do is we take the difference between that same thing, so we see the difference between the deflection at this level versus the deflection at the lower level, and divide it by its height there and turn it into a percentage. So we're seeing here what we've got, our drift and our ratio, and then we just kind of take a quick peek back at our numbers. They're pretty small. Service is listed here. We go to show the strength one. We still see a very small number for our drift ratios. These are not very large numbers. So our structure is not too much to worry about the story drift, but as your structure maybe changes shape, if you have less lateral resistance, you might have to worry much more about this. Now, as you think too, the big issue is more based on seismic drift. So what the program is doing automatically for you for the strength level combinations here, it's going to check this drift category for you. You define this drift category, and I'll show you here in a second where we do that. And you also define here your risk category or occupancy category, and then it will find whether it's going to be fitting into this chart. This chart here is based on the 2005 or 2010 ASE 7. So you've got this listed for you. And what we do is we check these numbers and say, okay, are we within range? If you are not within range, you'll get a red text. So it'll tell you whether you're falling out of this range level. The way that you define this, what you are, whether you're a high drift design, masonry cantilever, what type of structure you are, is defined inside the global model settings. So just clicking on that button up there, you'll see seismic tab. And then right here is a new entry called the drift category. So you can choose from what type of category you are listed here. Risk category is also shown. So depending on what type of thing, you're going to go right into that chart, and that will be what tells you whether it works or not. So this is all, like I said, automatically done for you every time you run a RISAFloor model. So it comes right into RISA 3D this way. But you can also just define this separately in RISA 3D. The next thing I want to show you here is about how to do that mezzanine level. So for example, if we put maybe a platform level in the middle of the structure and we don't want wind to be attached to it. So the wind loading is what, like we said, what's going to be smeared along the edges of the building. But what if you have something happening on the inside and you don't want to have wind applied to it? So what you can do is we're going to go back to RISAFloor. Let's just model that quickly for a second just to see how that would work. So open up our model here. We have floor levels here at 20 and 30 feet. So I'm going to say that we'll put something maybe just like a platform happening in at 10 feet. So what I'll do is I'm going to do a new floor plan. So I'm going to say insert floor, and we'll go break the solution, no problem. And we're going to call this platform, just so we can identify what it is. It's a beam supported floor. And the easiest way for me to do this is I always like to just copy the floor. So I'm going to say copy all the columns, let's copy the beams, everything, maybe not the diaphragms, but everything else we'll copy, and we're going to copy from above. And we're going to say that this is going to happen at 10 feet in our building. It'll be an office floor loading, it's going to be metal deck, and we'll just copy that 90 angle there. So we can say OK. And now we jump to this floor level. So what we'll do is we're just going to delete kind of everything around the structure that we don't want. So I'm just going to pick out what we want. We'll just pick out this is what we want to have in our structure. And I'm going to say, okay, inverse the selection state, and we want to delete everything else. Now the columns and the walls, we don't want to delete those. Those are running through. So what we will want to do is delete, let's go ahead and delete all of the beams. So let's say, okay, delete these beams. And now we only have columns and walls and then just that inner portion. So I'm going to select everything back again, and now I need to put my diaphragm in. So I'll go ahead and say create the diaphragm. I'm going to go ahead and say it's going to be 1/2 inch. This is going to be a semi-rigid diaphragm. Let's go ahead and make it a general steel with a a 1/2 inch thickness there. Okay, actually for our overhang distance, let's just give it more than a 1/2 inch. Let's actually give it like maybe 3 inches, something like that. You want to kind of go a little bit around the edge of that because we're talking center line here. So typically when you have an overhang, it's not really going to hit exactly at that center line of that beam. That beam has some width. So I like to say maybe 6 or 3 inches, something like that maybe makes a little bit more sense. Say apply, and then we get a diaphragm along the edge of that. Now, one thing I can do is just make sure that this kind of looks right. I like to always look at that full model view. I push the shift button, my middle mouse, and I can kind of rotate about and see what's happening in my structure. So you can just kind of see what's going on in there, like look in the platform, and we'll just kind of see about how that's happening. And that looks exactly what I wanted. I wanted to have that right in that lower level there. So what I'm going to do is let's go back to our lower level and double check one more thing on our platform. So we double click on this, we see, oh, okay, we've got our columns in place and they're drawn continuously, but they have that splice in the middle. And I didn't really intend that. So this happens kind of to people as they add floor levels, they've already run the model, things happen along the way. So what you can do to delete those is you can go to your column spreadsheet, and that splice is listed right there. We want to go to the floor that we don't want the splice on there. So when we're looking at this floor plan 1, that was our 20 to 10 foot, and it had a splice underneath it. So the way I can take that splice out there is I can just highlight on the entire column, right click and say fill this block. And I'm going to fill it with a blank, so it's going to uncheck that splice there. All those splices go away, and now I look at this model and I double click on a column and it says, oh yeah, looks like the splice is gone. That's what I wanted. I wanted a full height column there. Same thing happens with our wall panels. So when you make modifications to the wall panels, no problem. You can add on top and the below, up at the top, or whatever you need it to be. But then our regions are showing here are not on the underneath portion. So I can go ahead and manually delete them, but this is time consuming. So what I like to do instead is I can just say there's a tools button at the top, and it says delete all wall panel regions. When you delete them all, it's going to say delete all existing wall panels, and I say sure. Now the program will automatically put those wall panel regions in back there for you for every floor level that you have. So it's kind of like a clear button, clear all of the memory of that wall panel regions, and you're ready to go. So now, let's see here, I've gone through and I've run all of that information, so I'm just going to solve the model. It's going to calculate the loads down the structure, designing all of the gravity, again here in RISAFloor, doing all the gravity design, optimizing all of our shapes. We shouldn't see much difference happening here. Everything looks to be, it should be the same. We should just get a little additional design based on what's happening on that platform right there, but we're not going to really add load to the upper structure, so we should see really the same design up there. Okay, we can clear out and we'll keep with what we've got here. And now we can see we've got this lower level we've now designed, and we're attaching that to that lower level. So the one thing we forgot to do is we didn't turn off that wind loading. So let's just kind of see what happens if we don't do that. I just want to show you what's happening if you don't check that box. Just kind of obvious, but one of the things that we do is we're going to get wind load on that portion, and it kind of is hard to justify why you would get wind load there. There's a platform in the middle of our structure, 10 feet, and we can see that visually, and I like to always see things visually as well. When we get over here, we can see that we have a wind load. Remember we see it in the semi-rigid wind loads, and we can turn that on, and we see it kind of right in the middle of my structure, and that doesn't really make sense. So the way to fix this is using our checkbox. So we go back over to RISAFloor, and we're going to just go into the floor spreadsheet in RISAFloor, and we jump back here and we say, okay, just kidding, we actually don't want that platform to have wind or drift calculations. So I'll go ahead and uncheck that, and then I'm going to go ahead and solve the model one more time. Once we run through this now, it should be pretty quick because everything is already designed. Okay, we've got solution present, and we can get back over to RISA 3D. Now let's see what's happening over there once we've checked that box. So we see we're going to create new wind loads, and what we're missing in these wind loads is that platform. We still have those parapet loads, right? We still see floor plan 1 and floor plan 2 sees all the parapet loading that we had prior, but this time the platform load is gone. Now, one thing to note is that the seismic load is still there. So you still are getting the weight of the structure at that location. We're still going to see that we have a platform. It weighs 25 kips, and we're seeing force applied to it in the X and the Z directions. And that makes sense because we're not telling the program that there is no lateral load at that location. What we're saying is it's not going to be wind that we want to smear at that location. We really want to just see the weight of the structure there. So we're going to go ahead and say OK, and we get over back into RISA 3D, and now we can see when we go back to those wind loads, we should see nothing happening at that location, and we do not. We see it along the edges where we thought we wanted it to, but we would have gotten some earthquake loads. So we'll be smeared, kind of hard to see in there, but you can see below there, you've got some earthquake loads happening inside of that. So you've got the ability to now turn off your wind loads per the floor level if you have mezzanines or situations that don't need wind load on that level. That concludes all of our presentation here for RISAFloor features. I've showed you a lot of different tools. We have videos on our website as well as articles showing you some of the new features on our new features page. If you're more interested and have further questions, always feel free to contact us, info@risa.com. Otherwise, take a look at our website and for more resources. Thank you.